Hi, this IP Physics Past Paper MCQ is about the real cell, which is delivering energy to the external resistor as well as automatically internal resistance of the cell. So what we see here that this cell delivers 4 ampere current for the 500 seconds. By the way, when it delivers 4 ampere for the 500 seconds, so you can automatically find out that what total amount of charge that it has delivered, and that must be equals to 2000 coulomb of the charge that it has delivered in that time span. So the internal and external energy dissipations are 1500 joules and 2500 joules. So what you are supposed to find out is the cell's EMF. So we will try to find out by the two methods. This is the method one. This is a cell and this is its EMF and internal resistance, and this is the external resistance. In a practical circuit, what you see, this is a cell and internal resistance is actually the opposition offered by the chemical composition inside a cell, which is a chemical inside a cell, and this is your external resistor whom you are delivering energy, and this is the switch. So if you want to calculate the current, you can attach an ammeter in series, and if you want to find out the potential difference across the resistor, you have to attach the voltmeter in parallel. So, anyways, this is our circuit that you see over here. And how can you find out the cell's EMF? We should first of all know what is the EMF means. So the EMF is actually the work done per unit charge. EMF is the potential difference, the actually the potential difference of a cell. So we should say it is the work done per unit charge. But remember one thing, that this work done is actually the energy delivered. It is equivalent to energy delivered by the cell or a battery to move the charge across the circuit if the circuit is complete. So we can also say that the EMF E is equals to actually the energy delivered, which comes from the work done that a cell or a battery do per unit charge. So we should write it. So we have already calculated what is the total amount of charge that is flowing, and what is the total energy delivered is actually the total energy dissipated in the two at the two places. The one is the internal resistance, another one is the external resistance, and we already know their values. So that is 1500 plus 2500 divided by 2000 coulomb, right? So that is equals to 4000 divided by 2000, and it is equal to 2 volts. So this is a EMF of a cell, of this cell. And so option D is the right answer, which says it is 2 volt. Now let's talk about the method 2, which is, so let's start from the law of conservation of energy. You know that the cell is a main component that is delivering energy to the circuit. And the resistor, external and internal resistors, are the one which are dissipating and consuming energy. So if you follow the law of conservation of energy, after the few steps, you will see that the EMF of a circuit can be written as the potential difference across the external resistance plus the potential difference across the internal resistance. And I'm sure you are already you know this equation. So now what we will do in this method, we will try to find out the potential difference across the internal resistance, which is I small r, and the potential difference across the external resistance, which is I big R. By the way, for your information, this I big R is also called terminal potential difference if there's just one single resistor in a circuit, external resistor. Now, so what is the I small r? So I small r is the potential difference across internal, which we can calculate by the energy dissipated inside this, and which you know that is the uh, okay, this is 1500 joules divided by how much charge is flowing, that is 2000. 1000 coulomb, right? So that should be 15 over 20 is 3 over 4 volts, right? Now, what is the I big R is a potential difference across the external resistor, which we can find out by the same way, which is 2500 over 2000, and that will become 5 over 4. So finally, it is, you see that 2 volt is, once again, we get the same answer, and option D is the right answer.